In this video, we will work through the capital allocation problem where we have 5 projects. Those 5 projects give us a known return amount. So this would be for project 1, for instance, it would give us $300,000 in return. And it has some capital requirements. Each of the projects has capital requirements over the 3 years. And we have available capital that we can invest in the projects over those 3 years. We cannot exceed the available capital in any one of those years. Our decision is then going to be which of the projects should we invest in. Should we invest in project 1? Should we invest in project 2, etc.? These are variables that we're going to make equal to 1 if we invest and 0 if we don't invest. So let's say we invest in project 1 and project 2. Put zeros for projects 3, 4, and 5. We're going to maximize our return. That's the objective of our problem. When we're using binary variables like this, sum product, the Excel function sum product, will be handy because we can just do things like multiplier decision variables times the return. And if it's 1 if it's active and it's 0 if it's not, basically that's saying add up the return for all the projects that you invest in. We can do a similar thing with sum product for the constraints. So my expenditure in year 1 is equal to this decision variable array times the capital requirements for the 5 projects in year 1. Same thing for year 2. I'm going to use sum product of my decision variables times my year 2 requirements. And same thing for year 3. I'm going to multiply my decision variables times the year 3 array. I have available capital requirements, which I'm just linking to the inputs from my problem. So that is cells C11, D11, and E11. I'm going to make equal here. And we have one more constraint that we'll come back to later. I'm going to reset my model. Our objective is to maximize the return, so let's select our return cell. We're going to maximize it. We're changing our 5 variable cells. And we have some constraints that our expenditure cannot be more than our available capital for each year for years 1, 2, and 3. So there are 3 constraints there. We also have a constraint that these variables or decision variables are 0, 1 variables. So I'm going to select my decision variables. I'm going to select bin for binary, and now I have the constraint that these are binary variables. When I solve, let's see how much better I could do than the solution I made up. The optimal solution is to invest actually in projects 3, 4, and 5. Now let's say we add in an additional constraint that we can only invest in either project 3 or project 5. How could we implement that in our mathematical program? Our constraint of an either or type is actually pretty easy to do with binary variables. If our binary variables are 1 if they're active, and we don't want both of them to be active, then if you add them together, it needs to be less than or equal to 1. The sum needs to be less than or equal to 1. So let's add the decision variable for project 3 plus the decision variable for project 5. So the cells B17 to B19, that has to be less than or equal to 1. Now let's add that constraint and resolve. I'm going to add the constraint down here that cell B34 has to be less than or equal to cell D34. Click OK, click solve. And now the optimal solution is to invest in projects 2 and 4. So Solver said, well, if I can't do either 3 or 5, I'm better off not doing either any of them. So the optimal solution is to invest in projects 2 and 4.